Assalamualaikum guys, today we're going to talk about alkanes. Oh yeah, okay. Now, alkanes. The first thing you need to know about alkanes is that their functional group is no functional group. We've already mentioned that in our introduction to organic chemistry video. If you haven't checked it out, go and check it out and subscribe because to make sure to say that at the end of the video. Now, naming alkanes is the second part. How do we name alkanes? Once I understand what an alkane is, how can I specifically say I'm talking about this specific alkane? Because when we're dealing with compounds, we need to be specific, especially in medicine. We don't want to give the wrong compound, the wrong molecule to the wrong patient, or use the wrong thing to make the drugs, or anything like that. We have to be very specific in our chemistry. And so we need to have a systematic way of naming all our molecules so that everybody knows what we're talking about. Now, naming of alkanes, I've got 7 examples here and we're going to go through all of them. The first one is CH4. This is, as you can see, a condensed formula. If condensed formula doesn't work for you, expand it into a structural formula and then come back. If you need to, pause the video, take your time, draw it out before coming back. But if you can work with condensed formulas, that's great. Let's start moving. The first one is the most simplest alkane because it's only 1 carbon and 4 hydrogens. You can't get any smaller than that. You can't have a molecule that has 0 carbons because if you have 0 carbons, you aren't even a molecule. So this is called methane. Now why is that? The meth means 1 and the ane is corresponding to alkane. That's how we know it's an alkane and that has 1 carbon. You'll study alkenes in the next video. Alkenes end with ene. So all of their molecules will end with ene instead of ane. So each family has its own group, has its own suffix. For alkanes, it's ane. So this is methane. What about if you go 1 extra carbon? This is called ethane. So F means 2. What about 3? This is propane. Again, you can see we have ane at the end, and prop means 3. What about 4? This isn't something you've been very used to now. If you watched our previous video, this is called butane. 4 means but. Now you must be wondering, why is this like mono, di, tri, and quad, something like that? More systematic numbering. That's because we use the olden root words for the first 4. I don't know why they haven't changed it. I'm sorry, I'm not the guy who invented this method of naming, but this is how it is. The good news is, after 4, meaning 5 and above, we go back to our normal systematic method, which is 5 is pent, 6 is hex, 7 is hept, 8 is oct. After 5, it's all those normal prefixes you've heard. But for the first 4, you'll have to learn them. 5, this is the 1, 2, 3, 4, 5, and this is a straight chain. This is, what did I say? 5 and above is all exact, it's the normal method you've heard of. So 5 is pent, like pentagon, 5-sided shape. So this must be pent, and what does it end with? Ane. So pentane. Let's write that down. Pentane. And you can guess that the next one's going to be called hexane, heptane, octane, and so on and so on. Now these are all straight chain alkanes. What about branched chain alkanes? Now this is the tricky part. This is where you'll have to learn a couple of things. So over here, I can see I have 1, 2, 3 carbons with another carbon attached on top. How can I mention that? This is where you need to learn the alkyl groups. Now this is how we spell alkyl. A-L-K-Y-L. Alkyl groups. What's an alkyl group? It's simply an alkane with a hydrogen cutoff. That's literally it. Look at this. This is a CH3. Where did this come from? This came from a CH4 which is a methane. If you cut off one hydrogen, then it has an empty bond, and this bond is being used here. That's what an alkyl is. It's just an alkane with a hydrogen cut off. So if you can guess, if we had an ethane and I removed one hydrogen, so it became CH3, CH2, because it's supposed to be CH3, CH3, but I removed one hydrogen, became CH3, CH2 with a bond available. This does not become ethane, but instead ethyl, because see, it ends. This becomes ethyl. What do you think about propane? If I remove one hydrogen, it will become propyl. What about butane? If I remove one hydrogen, it will become butyl. What about pentane? If I remove one hydrogen, it will become pentyl. I can keep on doing this forever, guys, and you don't want me to. But that's how simple it is. Just remove one hydrogen, it becomes an alkyl. So this thing is a methane group with a hydrogen cut off. So what's a methane minus a hydrogen? Methyl. So this is a methyl. Now I automatically know I have to have the word methyl somewhere in my name because this is a methyl group. That's how we name it. But what about this? How do you know everything else? You have to see what the longest chain is. So in this case, it's only 3. 1, 2, 3. I can't go bigger than that. Even if I go up, 1, 2, 3, 3 is the maximum. So my main alkane is a 3-carbon alkane, which is propane. So I'll write propane. This is the alkane. However, it has some extra stuff on it. For example, a methyl group. So how can I mention that it has a methyl group on it? Well, I have to label that at the beginning. So if I write methyl propane, I automatically know what it is. But to take it even a step further, in this case, I can stick with methyl propane. But for bigger molecules, I have to mention specifically what carbon it is. So in this case, the methyl is on carbon number 2. How do I know? Because I labeled my carbons. If this is carbon number 1, and this is carbon number 2, and this is carbon number 3, the methyl groups comes on carbon number 2. If I go the other way, if I do, this is carbon number 1, this is carbon number 2, and this is carbon number 3, it still ends up on 2. So 2-methyl propane is the full name of the compound. What about this one? Now this is where it gets a little tricky, because you can have methyl, you can have ethyl, but when you get 3 and above, you can either cut the hydrogen from the end, or you can cut the hydrogen from the middle. And that's exactly what I did here. See what happens? This is a propane group, but the hydrogen was cut in the middle, so the middle carbon has a bond to give instead of the end. Because if it was the end, it would be very nice and simple. I would say propyl, but it's not. So what is this? This is what I'll get to you in a minute. First of all, let's find out what's the biggest chain I have. Well, 1, 2, 3, 4, 5. In this case, I have 5. Let's check another chain. 1, 2, 3, 4, 5. Still 5. Let's do something else. 1, 2, 3, 4, 5. Still 5. Whichever way you go, I'm going to get 5. So the biggest chain I have is a 5-alkane chain. And what's a 5-alkane chain? Pentane. So I'm going to write pentane. Now, of course I have this group attached. What is this? This is what we call an isopropyl group. What does that mean? Whenever you have something that's not at the end but somewhere near the middle, you have to add the word iso. What does iso mean? Isomer. So when I say propyl, I have 2 isomers of propyl. I have the one where it's at the end. Let me write that over here. If I have CH3, CH2, CH2, and then I have a free bond, this will be propyl. And then if I had CH3, CH, CH3, and the bond is in the middle, this is also a propyl. However, there are isomers of each other. So the original one, I'll call that propyl, and the other one, I'll call that isopropyl. because it's an isomer of the normal profile. So this is an isopropyl. So I'm going to write that down. Isopropyl. So I have isopropyl pentane, but remember, we have to mention which position carbon is at. So this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5. So number 3 is where the isopropyl is at. So this will be 3 isopropyl pentane. You thought it was over, didn't you? We actually have one more example. So let's do that one more example of naming before we move on in our alkane chapter. I kept this one on because this and these are isomers. They have the same formula, but different structural formula. But remember, we're naming the structural formula. Everything is different. So this will have a different name to this. But I wanted to keep that up to remind you that this group and this group is the same. And if this was isopropyl, this is also isopropyl. Okay. And if here the longest chain was 5, the longest chain here is also 5. So this is 5. So this is a pentane. And I write isopropyl before it. Okay, which position is the isopropyl on? Let's count. 1, 2, 3, 4, 5. It's on number 4, so I write isopropyl pentane. Wrong! It's not. You thought it was over. Well, it's actually 2 isopropyl pentane. Why? Because we're supposed to take the lowest number of carbon we can. If we flip the order of the carbon, so if I cross this out and we start 1 from this side, 1, 2, 3, 4, 5. Here, the isopropyl lands on carbon number 2, and that's much more suitable to us. So, scratch out the 4, write 2 isopropyl pentane. We did naming, now we're going to talk about the properties and reactions of alkanes. Now, there are 3 main properties that you need to know. Alkanes are odorless. They don't have any smell, they don't have any taste, they're colorless, they're nothingness, okay? Now, and they're non-polar. What does this non-polar has a very important advantage here, or disadvantage, depending on what you want to do. Because it's non-polar, that means it's insoluble in water. Because polar molecules can dissolve, small polar molecules or ionic molecules can dissolve in water. Anything else can't. So alkanes are actually insoluble in water. The last point is they're flammable. And because they're flammable, that leads to a reaction that they can do, which is combustion. Combustion. But before we mention on, we need to note that alkanes do not react, hence my not sign, and a big X through this thing, and another big X through this, and then another X, and then some more X's, and maybe some more. You know what, let's actually change our color and add some more X's to prove to you that alkanes do not react with acids and bases. Okay, these are organic molecules that do not react with acids and bases because they are neutral. You don't have a functional group. For heck's sake, they're non-polar. They don't even dissolve in water. I mean, give these guys a break, okay? They're not going to react with acids and bases. If you get an acidic organic molecule, it will react with a base. But this isn't. If you get a basic organic molecule, it will react with an acid. But this isn't. This is just a neutral, want to be left alone guy who doesn't want to do anything with the world. Okay? So let's leave him like that. Now the first reaction is combustion. What is combustion? It is the burning of technically anything with oxygen. It is the reaction of anything with oxygen. So let's draw out an alkane. Very simple alkane. In fact, the simplest is methane. So let's draw methane. CH4 plus oxygen. So, all right, O2. What does that give us? All combustion complete combustion will give us carbon dioxide and water. So let's write some carbon dioxide plus water. Now, you can tell that this is not balanced. How can I balance this? Well, I can say there's one carbon here, one carbon here, there's 4 hydrogens here, there's 2 here. I have to make this a 2 then. That's 2, 4 oxygens here, there's 2 here, so I have to add a 2 here. Now, the reaction is balanced. My lecture is not focusing on balancing reactions. If you're confused on that, you can go watch a video, but right now we're going to be talking about alkanes specifically. So that's combustion. The other reaction, which is a bit more interesting, is halogenation. Now what is halogenation? Halogenation is the reaction of adding halogens, surprisingly enough. Now, you guys know halogens are group 7. So these include fluorine, chlorine, bromine, iodine, etc. You know, there's only a couple of more that's in that group. For this case, let us take chlorine because I like chlorine. So I'm using chlorine. I'm going to draw methane, the structural formula of methane, and then I'm going to draw out the structural formula of a chlorine molecule. Now, if you remember correctly, chlorine exists as diatomic molecules. So if I take a methane and if I take a chlorine, what happens is this hydrogen, or in fact any hydrogen, will swap with a chlorine. So you end up getting the chlorine attached to a methane plus HCl. Now what happens is another chlorine molecule will come and react with this, swapping this hydrogen with a chlorine, and then swapping this hydrogen with a chlorine, and then swapping this hydrogen with a chlorine. So this reaction can happen up to 4 times, each time replacing a hydrogen with a chlorine. So you can get all sorts of products with this. If I use the same reactants, which is a methane molecule and some chlorine, and if after a while I stop the reaction, I will end up with many different types of products. Some will only have 1 chlorine, some will have 2, some will have 3, some will have all 4. So it depends on what this is. So we've done products, we've done reactions. That's literally, there's nothing more to reactions of alkanes. As I said, they're very unreactive because, one, they're non-polar and they don't have any functional groups. The only thing left is cycloalkanes, which we're going to be talking about in a minute. Okay, now we're going to be talking about cycloalkanes. What are cycloalkanes? These are alkanes that are in a cycle. They're in a circular chain. For example, over here I drew cyclopentane. How do I know? 1, 2, 3, 4, 5. 5 carbons, so it's a pentane, and they're in a circle, so it's cyclopentane. Let me write that down. Cyclopentane. However, sometimes it's very annoying to draw all the carbons and hydrogen, so you can use line structure. And in this case, it's a very simple pentagon. If you don't know what line structure is, please make sure you check out our video on Introduction to Organic Chemistry. However, cycloalkanes can get a little confusing sometimes, especially when we start to add some extra groups. So over here, I can represent that as this. Okay? Now, what is that? This is a methyl group. So this must be a methyl cyclopentane. So I'm going to write that over here. So I write methyl cyclopentane. Cyclopentane. And in this case, I don't have to mention what number it is because it's always going to be at number 1 because it's a cycle. So I don't have to mention this is 1 methyl cyclopentane. However, I will have to mention what number it is when we start to reach things like these. For example, if I stick an ethyl group over here, so this is going to be a CH3, CH2 group. that's attached to this carbon over here. So this is an ethyl group. So now I have an ethyl and a methyl group. What am I going to do? Well, if I have to see which one is the least labeling. So I can see this is 1, 2, 3, 4, 5. In this case, they fall on carbon number 1 and carbon number 3. What about if I do it the other way around? 1, 2, 3, 4, 5. And this cycle, it falls on carbon number 1 and carbon number 4. Now, obviously, that isn't the better example. I should try and go for carbon number 1 and carbon number 3. So I'm going to stick to a anti-clockwise counting rotation. So I have 1 methyl, and I have 3 ethyl. Now, how do I know which one goes first? We do it according to alphabetical order, believe it or not. So E comes before M. So I'm going to write 3 ethyl, 1 methyl, cyclopentane. And that is how you name cycloalkanes. However, one more last thing we have to finish off is actually draw that on a line structure. Remember, each point represents a carbon. So if here I have 2 carbons, I have to draw 2 points and join them together. So as you can see, here I have 1 point, here I have 1 point, which represents the methyl. Here I have 1 point, 2 points, which represents the ethyl. And the 5 points for the cycloalkane. Thank you for watching, guys. Make sure you subscribe to our YouTube channel, Meditorial, for more future videos on medicine. Dude, the channel's called Meditorial, obviously.